Confidence intervals are one way researchers attempt to describe how certain or uncertain they are of their estimates. Before a random sample is drawn, there is a 95% chance that this interval will contain the population's true mean. It does not mean that 95% of our samples will have the population's true mean, nor does it mean that given a realized confidence interval, there is a 95% chance that the population parameter lies within the interval. It does mean that 95% of future experiments will result in confidence intervals that contain the true population parameter. Even though not all those confidence intervals will be the same. Another way to interpret it is to say that there is a 95% probability that the calculated interval of some future experiment will contain the true population parameter we're interested in. Confidence intervals are used to describe a population parameter's likely value. A population parameter is the statistic we are interested in measuring. It is often the mean, proportion, or total count, but it could really be anything. Three things are needed to construct a confidence interval: a point estimate, a desired level of confidence, most often this is 95%, but any level between 0 and 100% can be chosen, and three, the standard error, which measures our sampling variability. So what does a 95% confidence interval mean? If we took 100 random samples from some population and computed a 95% confidence interval for each unique sample, then about 95% of the unique confidence intervals would contain the true population parameter that we're interested in. We don't do that because it's costly and inefficient and it would be insanely boring. Instead, we take one random sample and construct one confidence interval. Technically, this interval either does or does not contain the true population parameter. It is not providing a probabilistic estimate of the true population parameter's value. It simply provides a range of values which is likely to contain the population parameter. A good way to think about it is 95% of the calculated confidence intervals from future experiments would encompass the true value of the population parameter. Basically, the smaller the confidence interval, the more confident we are that our estimate is probably close to the true population parameter. If you'd like to explore any of these concepts in greater depth, I'd recommend KhanAcademy.com. You can find any of these concepts in short, helpful videos that have more in-depth examples and thorough explanations.